So today we're going to talk about how to prepare your data using Python and VS Code. And this is kind of a meta presentation because not only will I be actually guiding you through the workshop, but I'm also going to give you some tips and tricks to help you prepare to give this workshop to your communities. Something you'll want to do and something I will do just to start off is to let your audience know how they can ask questions during the meeting. In this meeting with us, it's pretty informal. So if you have a question, feel free to unmute yourself and just ask, or type it in the chat. I'll also be looking at the chat and we can get those questions answered. But you kind of want to give your audience a little heads up of how they can ask you questions throughout. The first thing that we'll do is look at the README page of the GitHub repository where this workshop is located. If this is your first time working with one of the workshops that my team has been working on, welcome. It's at the workshop library repository on GitHub as part of the Microsoft kind of folder. And in this workshop library, you'll find a bunch of workshops that are ready for you to give to your peers. And this is a full workshop, so we'll just head over to the one that we're talking about. And what you'll see at the top is a link to the source where the Learn module that we're following roughly is linked, and then we'll talk about goals. So this workshop is all about how to clean and prepare your data. This is data that's stored in a pandas data frame, which is a Python library. And if you don't know what that is, we'll cover it in detail, so don't worry. And what you'll need to do to participate in this workshop is set up your Visual Studio Code environment to run Python and Jupyter notebooks. This is pretty key, and I would say that if you are running this workshop, you might want to give folks a heads up ahead of time that this is going to be something that they need to download ahead of time, because it may take a little bit of time to set up, and if they don't have it set up, it might be hard to follow along. Some people like to follow along as you're guiding through the workshop, and some people like to just sit and absorb and then follow along later or rewatch the video. So all of those options are okay. It will be easier to follow along if you have that environment set up on your computer. And then you'll see the duration, the solution file, which I will talk about in a bit. It's pretty important to this workshop, as well as the PowerPoint. So this is the PowerPoint that I've created for this workshop, and you have access to this PowerPoint, to all of the notes in this PowerPoint. You can change the speaker name, the title, everything. You can actually make any changes to the slides that you want for the purposes of your workshop, which is really awesome, because if you realize that your style of teaching is a bit different, or you don't really want to use slides, or you want to use less slides, you're welcome to make any modifications that you want to the slides. And I will just walk through kind of the beginning here. So I talked a little bit about the prerequisites. All of these bullet points are actually links. So if you are giving this workshop, they'll be able to go to any of these links and understand how to set up the environment, which is what I talked about earlier. And then the learning objectives we're working with here are, we're going to figure out how to find general information about the data that we're working with. So it's going to be stored in a pandas data frame, which is a simple grid-like data structure, like a table. We're going to get a general knowledge of the ways that you can combine data frames. So sometimes you have data that's located in multiple different places and you want to put it together so that it can help you answer a question. We'll cover a little bit of that. How to identify and remove duplicate values as well as null values. You will see, if you've ever worked with a data set, that it's never perfect and there's always a little bit of cleaning up to do. And then finally, we'll learn how to visually explore the data. So a lot of people, when they start working with data science, you know that creating these visualizations is one of the best ways to learn more about the data and get some insights from it. So we'll cover the basics of that. And that's kind of what this agenda follows also. So do a little intro, talk about data frames, work with missing data, remove duplicate data, combine data sets, and then some visualization stuff. Are there any questions at this point about kind of how our next few 50 minutes together are going to play out? Feel free to go off mute or just write in the chat. Okay, if no questions, we will keep going. So let's start with a little introduction. And so say you find a data set on the internet. There's a lot of really fun data out there. Some of the data sets I've worked with have been the squirrel population of Central Park, which is a really big park in New York City. Some of you may have heard of. There's a group of folks who go around and collect data on the amount of squirrels and the types of squirrels and their behaviors, which I think is really funny. Or maybe you've seen this data set about the various types of French cheese. There's a lot of really interesting data out there. And the first thing you'll need to do with any of those data sets before you start working with it is to clean it up. There will often be missing information. There will often be formats that aren't in the way that you need them to be. And so in this workshop, we're going to figure out how we can use Python data science libraries to prepare and clean the data for analysis and visualization. And just a side note here, if you are presenting these slides, there are notes for you. And if you want to use the notes, if you don't want to use the notes, entirely up to you, but they are here for you if you want some help in, understanding how to structure the content of the presentation. So we're going to jump right in and start with exploring data frame information. And this is where I will talk about the solution file for this workshop. So kind of how I would suggest going through this workshop is to start off with the slides to talk about the introduction and kind of what we're going to be doing. However, because we're working with data science, you can actually just run the entire workshop from inside the Python notebook. And I will bring that over to my shared screen. So if you go, let me just show you where this is really quick. But if you go to the GitHub and you go to this solution file right here, you'll be able to download this Python notebook file. And if you open it in VS Code, it will actually give you this really, really nice Python notebook with all of the information that is also in the deck. So I might switch back and forth a little bit, but it's also all right here. So you kind of decide whether you want to use the deck or the solution file to go through it. So we're going to start by exploring data frame information. And data frames can be really, really big. It's basically a table with all of your data in it. And so a lot of the time, it's really hard to understand like what's going on in all of the different cells. And so we're going to learn a couple of really useful methods and functions to get a sense of what the data looks like without actually having to dive into it. So we're going to import the scikit-learn library, which is one of the data science libraries in Python. And the data set that we're going to be working with is the iris data set, which is a really popular biology data set. And you can also edit this workshop to use a data set that's interesting to you. This is just the one that the Learn module uses. So the first thing we're going to do is import pandas, which is our library, import scikit-learn, and then load in the data set into the data frame. And the awesome thing about Jupyter Notebooks is that you can just click play on a cell and it will execute the cell in Python. So this code has now finished running. And now we're going to use the info method to see kind of what's going on at a high level in this data set. So we know it has 150 entries in 4 columns, and we know that all of the data is stored as 64-bit floating point numbers. So these are kind of important details that we want to know about the data set, and this all loaded very quickly. So even though this data set is really big, we're using libraries and the functions to get a sense of what it looks like without actually having to dive deep or do really time-consuming calculations. So you can use the head method to learn what the first few rows of the data frame look like. So this will show you, here's all the columns that we have, and here's kind of what the values look like in all of those columns. Another tip I have is that you should make sure that you check the font size of your coding window. It's really important to make it clear and big for attendees, pretty much as big as you can, so that it's easier to follow along. So with the exercises, I would also suggest that you do the exercises along with the folks that you're presenting to. So let's try out this one. And if you have an answer, maybe throw it in the chat or go off mute. But so we just learned that the DataFrame.head method returns the first 5 rows of a data frame. How can we figure out how to get it to show more? And what you can do is look at the documentation. If you know pandas, maybe you might know the answer to this. Okay, Akshay says this. Let me just copy and paste it and see if that works. So we want to use iris data frame, which is what we called our thing. And then count here, I am assuming you know, is kind of like the count of how many rows you would want. So let's try to do 10 instead of 5 and see what that gives us. Awesome. Great job, Akshay. Cool. So then the flip side of head is tail, which is going to give us the last 5 rows. So let's just try that out quickly. So we see the last 5 rows of the table and kind of what those values look like. So each section will also have kind of like a main takeaway, which I think is a really great opportunity to just check in with folks that you're presenting to and make sure that they kind of understand what that takeaway was. So our takeaway here is that even looking at this metadata, you get an immediate idea about the size, the shape, and the content of the data, which I think are really important things when you first are looking at a data set. So does that make sense to everyone? Just doing a little check-in. If you have any questions, please feel free to come off mute or write them in the chat. Awesome. So the next thing in the agenda is to deal with missing data. And most data sets will have some missing values in them. And there's a lot of different ways to handle missing data, and they all come with different trade-offs. And so the more you work with data science and different data sets, the more you'll have kind of an intuitive understanding of which method you want to use to kind of deal with all of the missing data. So in this section, we'll talk about a few of those methods, and then this hopefully will give you a nice basis so you can kind of think about these things when you're working with your own data sets in the future. So in pandas, there's going to be 2 different ways that we handle missing values. The first thing, or the first way that it happens, is you'll get a not a number value, which I like to call NaN. I don't know if that's actually how you say it, but I think it's kind of funny. So we have NaN. And then for missing values that aren't floats, there's the Python none object. If you've worked with Python, this is probably something that's a little more familiar to you. And so the first thing we'll examine is the none. And this is, remember that it's non-floats. And we know that our data frame has 64-bit floats in it. We are going to look at this example array to kind of figure out what we're working with here. So we can see that the array prints out 2, none, 6, 8, and the data type is object. So there's some kind of interesting information here as you try to work with different methods in Python, you'll see how that none kind of comes out in situations like this. So for example, because there's no, you can't do a sum of a none object, if you try to do something like this, it will give you a type error. These should look pretty common if you're familiar with Python, because essentially you can't do the sum of a none object. So what we're trying to take away here is that addition and other operations between integers and none values, like a mixed array, like we just looked at, that gives you an error or an undefined value. So we're going to be a little bit limited in what we can do with data sets that contain none values. So not a number, nan, I'm going to call it because it's faster, but nan is like really actually useful in data frames because you can perform a bunch of operations on it using pandas. And so you're not going to get good answers, but you're also not going to get an error. So if we do something like this, you'll just get not a number. And if you do something like this, you'll also just get not a number. And yeah, like I just said, you won't get an error, but the results aren't really that helpful. And we'll look at another example here. So what do you think happens if you add not a number and none together? And if you think you know, or if you think you know what that code would look like to add those two things, can you type it in the chat? And I will paste it into this notebook and then we'll run it together and see what happens. So let's try it out and see what happens. Okay, so this kind of makes sense, right? Because we talked about how you can't mix none objects with other types in addition or subtraction or whatever integer type of operation you're using. So this kind of error makes sense because you're just going to get an error, a type error like we got originally. And this is a good reminder that not a number is just for floating point values. It's not for integers, strings, or Boolean. So if you have any of that kind of data in your data frame, that will give you some other issues that we probably won't get into during this presentation. Okay, so let's talk about how we can handle these in pandas. So if we have a series of integers that looks like this, how do we set an element of that series equal to none? And then let's figure out how we can get it to show up, how we can run some code that shows how it shows up in the series, and then what the type of the series becomes after we have a none value inside of the series. If anyone wants to help with the code, please paste it in the chat. We can walk through it step by step. So the first thing we'll try to do is set an element equal to none. So if we know that this is what the series currently looks like, let's try to set the last element equal to none. And then see if we can print it. Does anyone have an idea of what the type should be? Jingy says float. Let's try float. Perfect. Okay, so we know that if you have none, well, none is a non-integer value. So you can't actually have a series with mixed integers and none and have it be an integer value series. So it is a float, and it shows up in, it's pretty interesting because it shows up in the series as not a number instead of none. And you see that these integers actually show up as floats. So there's kind of a lot of Python, I guess like syntax and logic that goes into this. I think for the purposes of this exercise, we're just going to go over the methods that we can use to change our data frames because this is kind of what's important in cleaning data. So we have these methods, is null and not null. So we're going to use these to detect how much null data and where it is in our data frame. So they're going to return a Boolean mask that tells you if something is null or not null. So if we run this code to create a series and then we try to figure out where it's null, so we see that it shows a Boolean mask over the entire series, and we can see where the values are true and false. That would mean where they are null versus not null. And then there's kind of some subtleties here where like 0 is a integer, and so it's not null. And then this string object is also not null. We're going to go through this exercise quickly and just run this code. Does anyone know what we'd expect to see if we run this example 3 code? And this is example 3. I'll just paste it down here so everyone can see the two at the same time. What do we expect this line of code to show when we run it? Anyone? Okay, let's run it and see what happens. Actually, it says to return 0 and blank space. So we definitely have the zeros. We're going to see that these methods will be really helpful as we're working through our data frames to kind of see where those null values are. And then based on where they are and the types of values that they are, we, not a number versus none, will be able to understand how we can fill in those values in a way that makes sense for our data set. So one thing that you can do is to just drop them out of the data set. And so drop NA is the method. Drop na, whatever you want to call it. I don't really know how you pronounce these methods, but we're going to do that. And then we're going to print this example 3. So if you drop all of the null values, we're going to get what we just saw, which is the same as all of the values that are not null. This is an important note where you can't drop a single value from a data frame because they exist in a multi-dimensional table. So if you think about it as a table, it's a grid. And so if you want to drop something, you kind of have to drop a whole row or a whole column because each one of those rows is one data point, and it doesn't really make sense to just drop one value from that entire data point. So the default setting is actually to drop all of the rows that contain any null values. So we're going to use example 4, which is this 2 by 3 by 3 data frame. Oh wait, oops, I run this one. So here's our little data frame. And then we'll see that if you use this function, it will only return the one data point that doesn't have any not a number values in it. You can also drop them from columns if you use an axis. So what we want to think about here is, so we just used this on a table and it dropped 2 out of 3 of our data points that we had in this table, which is not really what we want to do. And so we're going to try to figure out how we can drop rows or columns that contain all null values or a lot of null values or some number of null values. And so we can use parameters in the function to create this kind of effect instead of just dropping all of the rows that have any null values. So let's try with this example. So how do we take this table and just drop column 3? We know that we have multiple parameters we can use with this function, like the axis parameter and the how parameter. Does anyone have a guess as to what that code might look like? So I think it will have, okay, actually said examples. Yeah, so the basis, the outline of the code here would be, oops, got your name in there too. So it's example 4. We're not using fill now yet. We're just using drop. So we just want to drop that column, not fill it yet. So let's do drop. And then yes, the rule goes here. So the rules that we need are the axis parameter and also the how parameter. And remember up here that you can use axis columns to drop values from a column. So I want to do something like that. And then the how, what do we think goes in the how? Jingy says if how equals all. Yep. So we're going to make how equal all. Let's try that. Cool. So we can see that using the axis and the how parameters with this method, we dropped the only column that had all not a number values. There's also alternative options like the thresh parameter. You can set the actual number of non-null values that it has to have in order for a column to be kept. So I'm just going to skip over this because we're kind of running a bit behind schedule. And we're going to talk about how to fill null values. Also, just note that this workshop, I think, is set to 1 hour and 20 minutes long. We only have an hour today, so I might be kind of skipping through lightly some sections, but the overall structure of the workshop is all documented, so you can lead the entire thing. So we're going to talk about filling null values, and Akshay kind of made reference to it earlier. There is a method called fill na to return a copy of the data frame with the missing values replaced in the way that you would like them to be replaced. So we're going to use example 5, which is another series that looks like this. And let's see what happens if we just want to fill all of the null entries with one value, something like 0. You'll see that in place of all of the not a number values, you now have 0.0. So let's see what happens if you try to fill instead null values with a string. So we have example 5, and we know that example 5 is of type float 64. So this may not make, intuitively, I think it should give us an error, but let's see what happens. So we're going to fill all the null values with, wait, let's just reset example 5. let's try to give it a string. Interesting. So it converts it to an object type series, and it actually does put the string hello where all of the not a number values were. So that's pretty cool. Another thing you can do is to forward fill null values, which means that you'll use the last valid value to fill the next not a number value. So we see here the original example 5 was here. So what it did was fill this not a number with 1.0, this not a number with 2.0, which was the last valid value. And then you can also use bfill to backfill the null values. And then you can also do it along an axis, which is what we kind of investigated in the drop na function above. Tell you later. So you'll see as you're going through this, there's kind of an exercise for each section. For the sake of time, I'm going to skip through some of the next few exercises, but if you have questions about kind of what's happening, or if you don't understand what these methods are doing, please give me a shout. You can come off mute or feel free to write in the chat. So something that you'll see is that one way that you can fill in null values is to fill them with the average of all of the other values for that column. And this is like something pretty common that folks do, and you'll kind of get a sense as you work through more data sets of when this would be a reasonable thing to do. So it looks like this. And when we run this, we'll see that the missing values are going to be filled with the average values in the data frame. And column 3 still doesn't have any values because the default is to fill them row-wise, and column 3 didn't have any valid values, so it's not going to fill those. So the takeaway of this section, which we'll just cover and make sure that everyone is on the same page, is that there's multiple ways to fill the data, the missing values in your data sets. And so there's a bunch of different strategies, and you kind of have to learn as you go which one is the right strategy and what kind of data you're working with. And so you will develop the sense kind of as you work through more data sets. Another thing you'll see really commonly is duplicate data. So you'll have the same data point represented multiple times in a table, for example. And there is a duplicated method, which is really useful, and you can use that to see what's going on. So here's the data frame we're working with, example 6, and you'll see that there are multiple duplicated rows, and if we run the duplicated method, it will show us which row of data has duplicated values or is duplicated. So we know that the second row and the fourth row are duplicated. And we can use this very simple drop duplicates method to just drop those from the table. And you can also specify particular things using parameters in this method, like we used in other methods. So moving on to a little bit of a more complicated section, we're going to talk about combining data sets, like filling in null values. There's kind of a couple ways to do this and a couple different reasons why you'd want to do this. In this workshop, we'll cover some of the common ways to do this. And if you have questions about specifics of any of these methods, please let me know, but we're just going to cover them as like an overview. And so There's a merge method, a concat method, and the combine first method. And first we're going to work with merging. And if you've ever used SQL databases, this may be familiar to you. So there's a bunch of types of joins you can do with merge. There's one-to-one, many-to-one, and many-to-many. And we're going to kind of, in this workshop, it goes through examples of all three. We're going to cover them kind of quickly, but they should all follow kind of a similar set of steps. And so the first thing we're going to do is the one-to-one joins. And this is going to talk about combining two data frames that contain different information on the same employees. So the first data frame looks like this. And the second data frame looks like this. So we have the same employees, Gary, Stu, Mary, and Sue. The first data frame shows what group they're in, and the second data frame shows their hire date. So what we're going to want to do is merge these two together. So for each person, for each employee, they have a group and a hire date in the same table. And if you just use the merge method, this is the output. So that kind of makes sense. It joined on the employee column because that was the only one that had a value in both data frame 1 and data frame 2. If we talk about many-to-one, it's kind of the same thing as one-to-one, except one of the two key columns has duplicate entries. So let's see how this data frame will handle that. So we're working with this as data frame 4. We have group and supervisor. And then we're going to merge this with the data frame that we just created that had group and hire date. So as you can see, because Stu and Mary were both in marketing, they have the same supervisor. And these methods are kind of quite smart when it comes to where they're going to join. So this makes sense. And yeah, kind of like what I said, if you don't specify which column to join on, the data frame or the method will use the overlapping column names as the keys. So it's generally pretty smart in figuring out where it's supposed to join, but if several columns meet the criteria, then it may be more complicated. And you'll use this on parameter to specify which column to join on. So finally, we're going to talk about many-to-many, and this is probably the more complicated join that we'll talk through. So again, we have the groups and then a column for core skills. And we're going to merge this with the original data frame on the column group. So this is kind of interesting, right? Because Gary is one employee, he's in the accounting group, but because there's two core skills for accounting, there are now 2 data points for Gary. Similarly for marketing and HR. In more complicated situations, there might not be any shared column names, which makes it really hard for these data frame methods to understand what column they're supposed to join on. And you can use left on and right on keywords to specify the column names on which to join. So let's look at this data frame. And then we know that the current data frame we're working with doesn't have a salary column. So we'll need to say that we're going to merge left on employee and right on name. And what we get out of that is this really nice table. So there's an exercise here. I'm just going to skip it for the sake of time, but feel free to go in and understand, kind of use the knowledge that we talked about in this section to complete these exercises. When you're actually running the workshop, you do want to allocate enough time to kind of go through the exercises together. It's been really great going through them with you all because you write your answers in the chat. We can talk about it a little bit. So yeah, and then left index and right index keywords make it possible to join by index, which is different from joining by column. So let's look at the earlier data frames and see kind of what this looks like. So we have our employees, we have their groups. We're going to set employee as the index, and then we have the hire date, and then we're going to merge on the index. So we have that. Just another way of merging separate data frames. So you can also use the join method. It's going to have a really similar effect, but it merges on only the indices. So that gives us the same output as this one above. And then you can also mix and match to kind of figure out where you would like them to merge in the table. Okay, there's kind of a lot more knowledge about the specifics about merging these tables. For the sake of time, I'm just going to skip through this little bit of it. And I want to come back with okay, so this is the part that I think is really cool. And if you're doing a workshop, this is what most folks who work with data sets or want to get started with data science want to see, and it's the visualizations. So obviously there's ways to, we just covered how to use pandas and scikit-learn and NumPy to do transformations on our data sets, on the data frames, and see how all of that looks when you print the table. And looking at tabular data can be really interesting, but another really awesome way to get insights from your data is to visualize them. So we're going to work with some basic statistics and visualization and kind of see what information we can get from this data set that we'll work with. So the data set that we're going to work with is a set of housing data. Oh, I do not have the file in here. Give me 1 second. I will fix this in the solution folder so that none of you run into this issue. Let's see if that works now. Cool. Okay, so we're working with this housing data set. We are loading it from a CSV file, which is also a pretty common way to get a data set in your hands. You'll get this file, and so what you can do is use the read CSV method to take all of that data and put it into a data frame, which we've now learned how to work with. So it should be a little bit easier to kind of get some insights from that. So we'll use the head method to kind of see what this looks like. The data set has 14 columns. This goes through what each of those columns are. And also remember that you can use any data set for this. I will put this particular data set, just because that's what the examples are written with, into this folder so you'll have access to it. But if there's another data set that you find more interesting, feel free to use that. We're going to use this shape method to see kind of what the data looks like first. And we know that it has 506 rows and 13 columns. That's a lot of rows. And we can use the describe method to return the maximum value, minimum value, mean, and standard deviation of all of the columns and the quartiles too. So if you've ever taken introductory statistics, this is all stuff that you learn to do kind of by hand. Using pandas, you just need to run the describe method and it will do all the math for you. So that's quite lovely. And so we have all of these numbers. You can also look at specific statistics without using the describe method. So if you just wanted to know the mean of a column, or if you just wanted to know the max of a column, you can use specific statistics methods to just get those values, or the median. So let's try this one out. Let's try to find the maximum value in the age column. Can anyone write the code in chat to see what that would look like? I think it would look something like df I'm going to do the age column. So I used the wrong brackets. And then max. Nice. Nice, Akshay. Yep, that is pretty much what we have here. And so other things you'll want to look at are the relationship between different columns. You can use the group by method to kind of see what are the averages within the age and the median value of owner-occupied homes. Again, this data set is just an example that has a lot of interesting column names, and so it may not be the most intuitive, but you can see the definitions for all of the column names here. Cool. So how can we use this information to find the median value for age for each value of med V, let's call it that column? So I think similarly, you would use group by. Oops. And then we have age. We have, oops, med B. In quotes. Oh, I did this wrong. Age. And then instead of mean, let's find the median. And we run that. Cool. So you kind of see how you can combine these columns and statistics methods to kind of understand more statistical data about your data set. In the last 5 or so minutes, I'll leave a few minutes for questions at the end. Let's just see one example of the kinds of visualizations that you can do in this workshop. So Seaborn is another library that we use in Python for data science. And you'll see these kind of import statements. This just means that you're going to import this library into your Jupyter notebook. And you can use the heat map function to create a heat map of the data. So let's kind of see what that looks like. So some of the different visualizations you can do are heat maps. This one will give us a histogram. There's going to be different kind of flavors of histograms you can do with bin sizes and such. A distribution plot, the joint plot, and this one is really fun. But yeah, so this workshop is designed to kind of give you a sense of the possibilities, and what I'd really like to encourage you to do is to bring in your own data sets to kind of understand how to clean and prepare and visualize them. And there's also a bunch more Learn modules that you can use to continue learning, like explore and analyze data, You can understand how to start doing machine learning with data, or you can do this really fun one that is about exploring the role of Python in space exploration. That's a personal favorite of mine. But yeah, that's kind of the overview of the workshop. I'm very excited for you all to present it to your peers. Does anyone have any questions about either the workshop itself or presentation tips or any other things you want to ask while we have 5 minutes left? And if you have feedback on this workshop, I'll just post this link in the chat really quick so that you can provide it there. And then if you want to get to that main repository page, the link is here. Cool. Well, thank you so much for joining. And if you have any questions, you can always message me on Teams. And I really appreciate having you all here. Good luck with hosting your own workshops. And I'm excited for you all to start checking out the workshop library. See you soon.